Good morning again, class. Ayan. Today we're gonna discuss electromagnetic induction. Okay. Electromagnetic induction. Medyo chika-chikahan lang to kasi more of, tawag dito, more of conceptual yung mga bagay-bagay natin ngayon. Okay, so sa electromagnetic induction, recap lang pala ng huli. No? Yung huli natin ginawa is tinapos na natin yung about sa mga magnetic fields ng mga bagay-bagay, Ampere's law, and yung mga integral for trying to understand how we get the magnetic fields. Okay? So, yan. Pero magnetic fields tayo last time. And you may wonder, di ba, nasa electric field, marami pa tayong ways of how to solve it. So aside from sa electric field, may Gauss's law ka, meron din tayong electric potential energy, and so on. Okay, but walang ganun sa magnetic field? Actually, meron, pero it doesn't make the work easier. Mas mahirap siya. Mayroon tayong tinatawag na magnetic vector potential. So wala din, vector din siya. Tapos may mga cross product din siya involved, and it does not make life easier as compared to sa electric potential natin. Okay, so yeah, so that's why tapos na tayo. Sa level nyo, tapos na tayo sa mga ganitong bagay lang. Okay na yan. Okay? And then we now move forward to electromagnetic induction. And then puntahan natin si Faraday, si Michael Faraday. Si Michael Faraday, wala lang, isa sa mga favorite scientist ko yan kasi wala siyang formal education, no? Si Faraday, wala siyang formal education. Meron lang siya mga books, and naging personal alalay siya ni Humphrey Davy. Kilala na siya, chemist. Humphrey Davy. So, assistant lang siya. And then, perks ng being assistant is that meron siya mga books and a laboratory to work on. Okay, so ang hilig ni Faraday mag-experiment lalo na sa electricity and magnetism. So interested siya lagi sa mga electric networks, circuits, ganyan. And of course, sa biology din interested din siya dahil sa mga eels, mga electric eels. So pinansin niya yung mga ganyan mga bagay. And then one day, si Faraday, one day, nagtitinker siya sa mga circuits niya. So, measure siya ng mga currents na nagko-flow through sa circuits niya. And then, habang nagwo-work siya, nagalaw niya yung magnet around a loop of wire. And it turns out it registered a current. Nagulat siya, wala naman akong sinusupply na kuryente pa. Okay? Hindi pa ako nagsusupply ng kuryente doon sa kung hindi pa ako naglalagay ng batteries. Kasi that time, ang ginagamit nila ay batteries. So, yung chemical reactions, ayun yung nagpa-power ng mga circuits nila. Gulat siya, bakit nung nilapit niya yung mga magnet, nag-register yung current doon sa circuit niya. Umilaw yung bulb a little bit. So, nagulat siya. Okay? Nagulat siya. So, baka anomaly lang in the nature. Ginawa niya, inulit niya yung mga bagay-bagay. Tinry niya ulit igalaw-galaw yung mga magnet. Tinry niya igalaw-galaw yung mga magnet around the circuit. And yes, it shows up. The current shows up. Alright? And then, one more thing, isang beses pa siya nag-experiment. Napansin niya na yung magnet may resistance siya towards a loop of wires, towards a loop of wires, singular yun. Okay, so parang paano kaya kung gamitin ko rin yung loops of wire toward another loop of wire, and it turns out merong effect na lumalabas na current. Okay, Tapos naisip niya, last, isa na lang. What if hindi ko gagalawin yung mga bagay-bagay, pero gagalawin ko lang yung mga current through that dun sa second coil of wire, second loop of wire. Okay, so pinasok niya yung second loop of wire to the first loops of wire. Okay, then binuksan at patay niya yung current. Napansin niya na nagre-register yon ng current doon sa kabila kahit wala naman nakasaksak doon sa kabila. Okay, so lahat yan sinulat ni Faraday sa mga experimental results niya na merong gantong bagay na nangyayari. Okay, so may ganong bagay. Pero hindi niya na characterize into an equation. He just knows it na if you have magnets, you have magnetic fields, they interact with loops of wires and they produce currents. Okay. So, nung dumating si Maxwell, nirevisit niya si Maxwell, medyo adik-adik siya sa math. So, mahilig siya sumali sa mga competitions, math, ganyan. And then, nabasa niya yung mga publications ni Faraday. Then, inisip niya, tinry niyang ilagay formally into math yung nangyayari dito sa experiments na ito. Sinulat ni ni Maxwell yung equation na to and giving honor to Faraday. Okay? So, yung yung change in flux, magnetic flux, can result into a potential difference, epsilon. Okay? So, potential difference itong epsilon. Parang dati lang. Okay? And then, ayan, when flux changes, meron daw yung napoproduce na potential and it's the reverse. Okay? So, may negative sign. So, intindihin natin mamaya. And then, yung magnetic flux would be a familiar mathematical object to you kasi electric flux na tayo. Okay? So, yung same process lang naman, B.A or B.DA if infinitesimal yung inaaral mo. Okay? So, whenever you have something like this, you have a magnetic field B going through some circular plate, okay, which is pointing towards here, parallel with the direction of the magnetic field, then you would have something like B times A. B dot A would be simply BA, and then if it is at an angle, let's say something like this, tilted, at some angle theta, then BA would be a cosine theta. Okay, so nothing new. Ito pa rin yung dati. And then, syempre, pag humiga na siya, perpendicular na yung mga vectors, mag-zero out lang to, and so on. Sir, akala ko ba yung flux sa magnetic field, zero lang? Okay. So, trick question na naman, no? May mga gantong bibigay ako sa exam na mukhang may sinusolve ka, pero wala ka talagang sinusolve. Kasi, pag kinlose mo ito, mag-zero yan. So, phi at a closed integral, ibig sabihin closed yung area mo, is always zero. Naalala ba natin yun? So, this is from lesson 9, I think. That is that here or here? Lesson 8. I think lesson 8. So, may Gauss tayo for magnetism, which just means that if you close the magnetic field through a surface, pag sinaraduhan mo siya ng surface, mag-zero out lang yung flux niya. Okay? Kasi sabi ko nga, pag closed yung surface, tapos yung magnetic field mo, it loops around, bumabalik siya sa sarili niya. So yung lahat ng lalabas doon sa surface na ginamit mo, papasok lang din siya pabalik. Okay? So sample, meron kang ganyan, and yes, may magnetic field niya na pa ganito. Forgive my drawing. Yan, pag ganyan siya. Then if i-close mo to ng some sphere or whatever area, mapapansin mo, yung mga lines mo, pumapasok lang and lumalabas, then bumabalik. Okay? And it zeroes out. Unlike sa electric field, may plus sign ka dyan. Ginamitan mo siya ng, so yung field niya pag ganyan, di ba? Radially away. It radiates. Pag ginamitan mo siya ng Gaussian surface, it's nice kasi lahat lumalabas lang. Okay? Lumalabas lang. And they are all nicely perpendicular with the surface. Okay? Or parallel to the area vector. Okay, so going back, here in this case, hindi naman closed, so we have a magnetic flux. Alright. So, for a while, tingnan natin kung ano yung itsura ng mga bagay-bagay. So, let's try to draw here a magnet. So, very conceptual lang itong bagay na to. So, draw here a magnet. Okay, north-south. And then, let's draw its magnetic field carefully. Gagandahan ko na yung drawing ko dito. Yan, maganda na, no? Okay. So, simplified version lang. Auntie lang dinidrawing kong field lines. Okay? So, yan. I think I could scale this down a bit. Ayan. Okay, so yan. Let's have it like that. And then, let's try to draw a loop here. Okay. Ay. Okay, so let's try to draw a loop here. Meron tayong loop of loop of wire. So, may loop of wire tayo. Then, intindihin natin kung paano yung mga directions ng mga bagay-bagay. Okay, so let's first understand what Lenz's law gives us. Okay, so in Lenz's law tells us the direction of the magnetic induction is such as to oppose the cause of the effect. Okay. In easier terms, I think nature, mas feel ko mas madali itong terminology na to. Nature abhors change. Okay? So, ayaw ng nature ng mga changes natin. So, ang gagawin ng nature is that i-oppose niya yung mga bagay-bagay. Okay? So, dagdagan mo ko, magbabawas ako. Binawasan mo ko, magdadagdag ako. Okay? So, parang ganun yung idea nung sa lenses ko. So, when we have this, let's try to understand now what happens when we try to push this magnet towards this current loop. Okay, so let me do that. So when I do that, papasok natin, no? Towards to the right. Okay, so pasok natin pa ganyan. And then what happens is that so ilalagay ko sa blue yung green na lang. Green na lang yung induced magnetic field. So, nangyari, si loop of a wire, naka-receive siya ng increasing flux, increasing magnetic field lines. So, ang gagawin niya, kukontrahin niya yun. So, magpo-produce siya ng pagganito. Okay? Magpo-produce siya ng layo ko muna. Layo ko na onti ito. Hanggang dito lang. Yan. Okay, isipin nyo na lang pumapasok yung magnetic field lines. Okay? So, dahil may pumasok na going inwards through this loop, magpo-produce ako ng magnetic field such that ika-counter ko siya. Okay, so this is what Lenz's law means. Okay? And when we have this kind of magnetic field, yung green natin, okay, this points out that the current that is flowing through the loop is by the right-hand rule. So mag-right-hand rule ka dito sa green na direction. So yung thumb mo nasa green, no? Tapos mag-circulate yung mga fingers mo towards this loop. So this means pa ganun yung loop. Okay? So ito yung side na mas malapit sa atin. Ito yung side na mas malapit sa atin. Okay? Okay. Alright. So pag may pagantong current, ibig sabihin yung potential mo, yung potential difference mo across this loop is great. Mas malaki dito sa side natin kaysa dun sa side na kabila, kaya umiikot yung current that way. And that is what is meant by or VAD. Kung ito yung point A and yung point B nasa likod. Okay? This is what is meant by this equation. Okay? So yung change in flux, 'di ba? Ito yung input ko. So this is the magnetic field and this is the area of the loop. Tama? Mapansin nyo, nung pinasok natin, ibig sabihin, Phoebe at our case, for this case 1 is greater than 0. Tama ba? Kasi increasing, di ba? Increasing yung flux natin. Okay, increasing flux. And mapapansin mo, yung direction ng current nito dapat, di ba? So, drawing tayo ng imaginary loop of wire here. To produce this kind of magnetic field, it should be going this way. Tama? Okay? It should be going this way to produce this kind of magnetic field. But since we're talking about the induced magnetic field, naglalagay tayo ng negative sign. And as you can see, no, pabaliktad na yung current dito sa induced. Okay? Kaya siya may negative sign. Okay? So let me just remove that imaginary loop of wire. Okay, so we have this. Okay, so ayan. So first case pa lang to na pumasok yung magnet natin. Magnet natin towards a loop. Okay. What if, let me remove the induced magnetic fields. Okay. So case number 2 na tayo. Let's have this. Okay, so meron tayong same pa rin, loop of wire, the blue. And then what we want to do right now is you try to eject out the mula dito i-eject natin pakaliwa yung magnet natin. And nagpalit ng color. Ano ba yan? Pansin natin na by doing that, natatanggalan ng magnetic field yung loop of wire. Natatanggalan siya ng current and nature doesn't like that. Okay? So nagbabawas ka sa akin ng current ngayon, nagbabawas ka sa akin ng magnetic field ngayon. So magdadagdag ako pabalik. Gagawin nung loop of wire mo is magpo-produce ako ng paganito. Kasi tinatanggalan mo ako ng magnetic field. Okay? So, ayun yung nawawala sa kanya, di ba? Ito yung itsura na nawawala sa kanya. So, i-restore nung current yun. I-restore nung loop of wire yun. Okay? To produce this kind of magnetic field. Okay? And then, what would be its direction? What would be its direction? Direction naman nito would be right-hand rule lang nito. Mas malapit sa atin itong wire na nasa kanan. Tama ba? Okay. So, yan. Right-hand rule. Ganyan pa. Okay. Points toward that point. Okay. So, that's case number 2. And then, what if baliktarin natin? What if baliktarin natin? So, let's try to... Guys, puro conceptual yung tanong nito sa exam. So, ayan, napakahalaga nitong magnetic induction and yung direction. Kailangan siya ng practice. Okay? So, you try to do some reading in your book and then some exercises. Pwede. How do I rotate this guy? Can I rotate this? Rotate, yes. Flip horizontal. And then try to flip vertical. So, weird pa rin. Ayan, binaliktad ko yung magnet, guys. Okay. So, what if ganito naman? Ganito naman. Let's try to insert this magnet towards the loop. Okay? So, insert ko siya, papasok dito sa loop na to. When I do that, when I do this, anong gagawin niya? Dinadagdagan mo siya ng papalabas na magnetic field. Ang weird, no? Dinadagdagan mo siya ng papalabas na magnetic field. Therefore, gagawin ng current, ng loop of wire mo is to counter that. So, gagawin niya, magpo-produce siya ng paganito. Ay, sorry. Produce siya ng paganito. Okay? So, ganda pala dapat din drawing ko sa kabila. Okay? Yeah. Siyempre, continuous naman yan. So, dinodrawing ko kanina isang side lang na kasi nakapagod mag-drawing. Pero it's continuous. Continuous. Okay, gets ba kung bakit ganyan? Kasi dinadagdagan mo siya ng papalabas na current. Okay? Ay papalabas na magnetic field, sorry. Therefore, it tries to counter that by opposing the direction. Okay? So we have that. And then if we try to eject now the magnet out of that loop, we'll have something like this. Let's try to move this guy. Okay. Let's try to move this out. And then what happens? Anong nangyayari? Si magnet, tinatanggal niya ng direction na paganito itong loop na to. Natanggalan niya ng magnetic field na ganyan. So the loop of wire would try to restore that. Therefore, gagayahin niya yung itsura nung field na yun na nawala sa kanya. Kasi it doesn't like change. It doesn't like okay? So, gayahin natin yung direction. Okay, so you have this. Siyempre, again, tuloy-tuloy to. Meron siyang papaganito in this case. Ganyan. Ayan. Okay, and then this configuration, yung current direction niya would be like this. So again, itong kanan, mas malapit sa atin. Okay, right-hand rule, right-hand rule. Okay. Mapansin nyo dito, gawin natin siya mathematically. The phi, B, is less than 0. Less than 0. Kasi decreasing siya. Well, yung derivative with respect to the time, decreasing siya. So, dapat pala kanina ganun din. Okay. Kasi flux is always positive. Pwede yung balik rin yung area pero that wouldn't make sense. It would make sense, okay, in some cases. Okay, pag closed yung area, importante yung sign ng phi. So, pwede pala mag-negative yung phi, tama. Okay? But in this case, ang mahalaga is yung change ng phi. Okay, for this guy, yung papalabas na yung magnet, it would posit a negative change in time of the flux. Decreasing. Okay, decreasing yung flux. Therefore, na-negative pa natin yun to understand what the direction of the current is. Okay? And from that, makukuha natin, positive yung makukuha natin dito kasi negative times negative, positive. And that would imply na same direction siya nung current na current na imaginary current na nagme-make nito. Nagpo-produce nito. Ang current nito ay pa ganyan. Imaginary current. Okay? And then, as you can see, same direction. Same direction. No? So, mahirap dito, ma-visualize yung directions ng current dito. No? Medyo magulo siya. Pero, kailangan mo maintindihan yung figure, yung image analysis kapag ginagawa mo siya. Okay. So, ayan. That's the electromagnetic induction. So nature abhors change. Ay, may nilagay pala akong ano dito. Okay. So, lahat to ginawa natin kanina. May, may motion lang yung atin para maganda. Ay, may hindi ako nalagay na slide. Ano ba yan? Okay. Mathematically, this implies another relation. So let's write it down. Epsilon, or the potential difference, negative ng derivative ng flux, magnetic flux, with respect to time. And we know epsilon to be a integral, line integral for AB. Line integral dt. Okay, so wala lang. Ayan. May ganito. Okay? And then if for di ba yung phi and yung magnetic flux is in terms of B times A, and if by chance A is constant, then yung changing magnetic field lang yung nagmamatter. Okay, and what does this imply? Changing magnetic fields produces electric fields. Okay? And vice versa. So that is what ayun yung essence ng electromagnetic induction natin. So you change the electric field, you produce a magnetic field. You change the magnetic field, you produce an electric field. Okay? So we now have, let's try to understand this emotional EMF. Okay? Suppose we have this kind of setup, may conductor ka, and then you bombarded siya ng magnetic field going into the surface. Okay, and then you have a movable, adjustable or movable branch of wire here, bar of wire here, or bar of conductor. And then this conductor would contain, of course, charges, electrons, and whatnot. Okay? Okay, so let's try to just look at one charge inside the conductor. Ito yung bar of conductor. And then you have a positive charge here inside. Okay, you have a positive charge there. And then you try to move this whole bar. Tapos meron kang magnetic field, di ba? Pointing towards into the surface. Okay, so when you move the bar of ginalaw mo yung conductor dito towards the right, then meron kang Q times V. Ginalaw mo to ng velocity V. Okay? Meron kang QV kasi may mga charges kang gumagalaw towards the right. And then, do you have a magnetic field? You have a magnetic field going inward. And those two, yung velocity mo, is perpendicular naman sila with each other. So therefore, this whole thing is just Q, V, B. And this is the force, diba? Force ito. So your charges are forced. They experience a force going. Let's do a right-hand rule here. So by the right-hand rule, the force is going upward. Okay? And kung mapansin mo, there are a lot of charges in that conductor. No? So pag ginalaw mo yung bar of conductor towards the right, you produce a current going up. Okay? Kasi hindi lang naman isang charge yung magagalaw mo. So lahat ng charges inside that conductor would go up. Therefore, it produces a current going up. Okay? So pag ginalaw mo yung bar to the right, may pinoproduce kang current going up, and the current would rotate around this circuit. Okay? Around this conductor. Amazing. Amazing. And then from here, you have QE, diba? That tells you that E is equal to VB. Okay? Mapapansin nyo dito, cancel out mo yung Q, you have VB, and then yung potential for some straight direction, you have E times D. Parang sa capacitor lang. So whenever you have a straight direction lang na pupuntahan, ganito lang yung potential. And this is VB times D. What else? Or times L. Times L. So the potential difference, L na lang. So L gamit mo ano. L gamit mo dito. Okay? The potential difference V is given by BBL. V is here. Yung maliit na VI velocity. BBL. Okay, so you have that. You have this. So for this kind of setup, pag ginalaw mo yung bar of conductor, yung maproduce mo na potential would be this guy. But in general, no, in general, you can write it down as something like this. Okay, kapag weird stuff na yung yung shape ng conductor mo, you can always have something like this. Okay? Okay. So let's try a weird guy, weird shape of conductor. So we have here a conducting disk with radius r that lies in the xy plane and rotates with a constant angular velocity omega about the z-axis. So let's try to understand that. XY plane, nakalatag yung disk mo. And then its axis of rotation is towards the C. Okay, makes sense. Constant omega. And then what happens is that, okay, we need to find the induced EMF between the center and the rim of the disk. Okay, so kasi pag ginalaw mo yung yung conducting disk mo, pinaikot mo siya, ayan, meron tayong direction na green here. Meron tayong direction na green. So, umiikot yan. Pag ganyan, di ba? Okay? And then may mga charges ka. Amazingly, yung charges na yan, they're all perpendicular. The motion of the charges is always perpendicular to B. Okay? Kasi nasa XY plane yung direction ng velocity and the magnetic field is towards Z. So they're always perpendicular with each other. Nice. Okay, so you have this. You have this setup. Tapos, so yung V cross B mo, for this case, is just VB. Okay, VB. And then, so that's for every element small element na, kasi di ba yung velocity dito mas mabilis kaysa dito. Okay? So yung mga charges na nandito, sila yung may certain velocity na mabagal, and yung velocity dito, sila yung mga charges na nandito, sila yung may velocity na mabilis. So radial yung dependence ng velocity. Okay? Mapapansin niyo yan? Radial yung dependence niya. So we have to integrate it. We have to integrate it. There's no choice. Okay? So we have to integrate that. Okay, and mapapansin mo, itong V cross B, anong direction nito? It's always radial. Okay? So R hat. And then, we can integrate radially rin kasi as we increase the radius, nagbabago yung velocity mo. Okay? So we have something like this, VB R hat. dot yung DL na lang, which is yung radial din na component or VR. Okay, so we have V, V, VR. Okay? And then V again is, sabi ko nga, radially dependent siya dahil mapansin natin, mas mabilis yung ikot sa gitna kaysa dun sa labas. But you can neatly write it down as yung given naman tayo ng omega. So, this is just V over omega R pala, di pala. Yan, R omega. V is equal to R omega. Yan. Kaya rin siya mas malaki sa gilid, okay? Kasi mas malaki radius doon. Pero you can just imagine that intuitively. Okay, so we have something like this. Omega R d R going from 0 to the center to the edge, which is R. Okay, and this is simply omega B R squared over 2, tama. Integrate lang natin normally, and this is just evaluated from 0 to R. So omega B capital R squared over 2. So this is the potential induced, EMF induced. Okay, let me just check that. Okay. Sama naman. Ayan. So you have that. No, patapos na tayo. Patapos na pala. Joke lang. Kalahati pa lang. Okay. And then what else? What else? Ito parang feel ko na lang to. For fun lang. For fun. So whenever you bombard moving conductors with magnetic fields, currents, you produce currents, no? Napansin natin dito na meron tayong yung disk natin, binobombard siya ng magnetic field that is perpendicular to this conductor. Napansin natin, there is a current induced radially. Okay? So may current na dumadaloy going radially. And they would all flow down here. Flow down yung ano dito. Current dito, then babalik dito sa gitna, tapos mararadiate siya sa disk yung current. Okay? So whenever we bombard the conductors, moving conductors with magnetic fields, we produce currents. However, tingnan natin the example na to, no? We bombard a certain place lang, a certain place, and conductor that is spinning. Okay, so let's say this is inward to, inward. And then your direction of the spin of the conductor, the disk of conductor is this way, clockwise. Then by the right hand rule, yung forces na may experience ng charges in this conductor is ano ba ito? Hindi ko na-gets yung ano. Okay, so the direction is going like this. So wait, V. Hindi ko ma-imagine, sorry. Then I have V. Therefore, V cross B is downward. Okay? So, downward yung ma-experience ng charges mo. And then, syempre, hindi lang naman isa yun. So, they're a continuous stream of charges. So, may going down ka na currents. Ayan, makikita nyo. And that currents would go back. So yung mga nandito, since umiikot yung tawag yan, ikot yung disk mo, after matapos nung spin niya dito, hahatakin na siya pa ganun nung conductor, and it would circle back. Dahil kailangan ma-close yung ano. So, hindi niya iikutin ng buong ganun. Mas circle back lang siya dito. Okay, mas circle back lang siya. And then, since may current ka, may current ka na pababa, may current tayo na pababa, ganyan naman, I. Okay, I. And then, you have a magnetic field again, going to this, into the page. Tapos, IL cross B, the force is given by IL cross B. So, this is the force. Okay, so may force na nararamdaman yung mga currents na yun. And that direction is opposing the spin of the rotating disc. Okay, ang galing, no? Kasi pag binombard mo tong disc ng magnetic field, what happens is that binibreak mo. Break. Yung rotation ng disc. Okay, kasi may nagpaproduce ka ng force na opposing the rotation. Okay. So, ginagamit tong gantong braking sa some technologies na gumagamit ng magnetic fields in braking. Okay? Hindi ko alam kung ginagamit sa maglev trains, magnetic levitation trains. And then, yung gantong concept ng eddy current. Si eddy ay hindi ano yan. Eddy ay hindi pangalan yan. So, word siya. Basta swirling currents siya. Okay? Tawag dito. Sa pa ba siya useful? So, sa mga dun sa dinadaanan natin sa mga mall na or whatever, yung may tumutunog na toot pag pinapasukan mo sa mall. So, gumagamit siya ng concept ng gantong eddy currents, no? Binobombard ka ng magnetic field, and they try to make currents in your conductors inside your body. Okay, kasi yung mga explosive natin, malalaking conductors sila. They're big conductors. So, they produce a certain amount of magnetic field. Okay? Kaya pinande-detect sila. Metal detector sila in a nutshell. Okay. So you have this for your magnetic induction. And then you might have wondered. Last time we have our tawag dito, capacitors. So parallel plate capacitor, something like this. You have a capacitor connected to something. Another capacitor here, and another plate here. Okay, you have this parallel plate capacitor. And then, so walang laman yung gitna, di ba? Walang laman yung gitna. So, some of you, baka medyo curious ka in life. Ginamit natin siya sa mga circuits, di ba? So, yung naka-series na capacitor sa circuits. And then, may relationship sila. Tapos, tataka ka, no? Sir, paano siya nagagamit sa circuits kung walang laman yung gitna? paano dumadalo yung current. Paano dumadalo yung current? Isipin natin, tumatalon yung mga charges. Tumatalon yung mga charges pababa. Kaya may current tayo, sir. Well, that isn't the case kasi kapag pinlog-in mo kapag nag-experiment ka, okay, let's draw a little bit of a circuit here. A resistor, and a conductor, and a capacitor, I mean. So you have some circuit like this. Then you open this circuit for a very long time. And mapapansin mo na nagiging disconnected ito. Wala nang at T approaching infinity, yung current dito I becomes 0. Okay? And this is expected, no? Expected natin yung current na 0 kasi ito yung unang intuition natin. Na wala naman dapat magpa-flow dyan, di ba? Wala naman dapat magpa-flow dyan. Kasi wala namang material there for the electricity or the current to pass through. This is what we expect. Okay? And this is what happens in real life. Kapag sinaksak mo yung capacitor mo sa isang source, wala nang current na nagpa-flow through at T infinity. Pero meron no. T 0 kung kailan mo sinaksak yung source mo dun sa capacitor, I is greater than 0. So may current siya at the very start. And that's baffling. Ano siya. Bother siya if you think about it. But then Maxwell, na-curious din siya dun sa bagay na yun. Kasi napansin niya yung mga equations na nagawa niya sa Ampere's law lalo. Nirevisit niya yung Ampere's law. Napansin niya, parang may mali. So dahil addict nga siya sa math, medyo nakikita niya na yung mga form ng mga bagay-bagay. Okay? So let's try to revisit Ampere's law. B.TL must be equal to U naught I enclosed. Okay? Okay. And now, yung DL here is the path of the edge of a surface. Mathematically, this does not limit us kung anong surface yung pipiliin mo. So kahit anong surface gamitin mo, tapos titignan mo lang yung sa path nung pipiliin mo, sa edge ng surface na yun. This works. So this equation works dahil it's bounded by math. Okay? So kahit anong piliin kong surface, basta same yung path, dapat same lang din makukuha ang sagot. Okay, so let's try this. Let's try the circular B.dl. Kasi alam natin yung current natin, nagpo-produce siya ng magnetic field that is circulating around it. Ayan. So IC. Tapos meron niyang magnetic field na nagro-rotate pa ganun. Okay. Imagine niyo na lang paano mag-draw. Okay. Kaya napili natin DL would be going around this. Okay? And then, first things first, try natin yung usual na ginagawa natin, which is yung planar na surface lang. Kasi parang hindi na komplikado yung buhay natin. So, let's try that planar surface only. And then, let's do the Ampere's law. So for that, B.dl, B times yung path natin, which is yung circumference lang, di ba? circumference lang nito. Assuming na radius r to, no? Assuming radius r. And then, equal to sa mu naught I enclosed. Meaning, yung nag-pass through na current doon sa surface na pinili ko. Okay, so pinili natin surface is the planar surface. Ito ang plane surface na to. In this circular loop. So, meron tayong circular plate in essence. Meron tayong circular plate. And the one that is flowing there is IC. Alright? And then let's try to do Ampere's law again for another surface. Let's try this bulging surface. No? Kung saan yung surface na to, sinasalok niya yung space doon sa kinukuha niya yung space doon sa space between the capacitors. Okay? In that part, same pa rin yung left-hand side kasi sabi nga natin, ito lang yung importante, di ba? Yung edge lang. So, B times 2 pi r pa rin yan. However, yung right-hand side mo magbabago. Dahil 0 na yung na-enclose mong current ngayon, kasi napansin mo nga, dapat walang nagpo-flow through na current dyan. Okay? Napansin mo, dapat walang nagpo-flow through na current dyan. So this, as you can see here, meron siyang contradiction. Meron nangyayaring contradiction. But that shouldn't happen dahil this equation, it holds for everything. For everything. Nag-hold dapat ito. So there must be something wrong, sabi ni Maxwell. Nagulat siya. There must be something wrong. So let's try to understand in the language of the capacitors. Let's try to resolve this. We have, for capacitors, we have Q times is equal to CV, where Q is the charges in the plates, on the plates. Okay, on the plates. And then V is the potential across the plates. So meron tayong bagay na ganito. And then, alam natin na this is yung capacitance ng parallel plate capacitor is epsilon naught A over D V. Tama? Tama. And then V can be written down since linear lang naman yung in a straight line lang yung electric field mo. This is actually epsilon naught A. This is a simplified derivation of things. Of course, lang tayo para hindi tayo mahirapan. There is a more formal way of doing this, but let's just try to do this with the things that we know. Okay, so D cancels out and you have epsilon naught A E. And then, let's try to get the current. Weird, no? Na kinukuha natin yung dq over dt kahit wala namang charge na nagpa-pass through. Pero, yung dq over dt in this sense is the accumulation of charges on the plates. Okay? So, pag nag-accumulate yung charges, meron kang dq over dt. Okay? So, make sense tong ito. Sin mo that this is just d over dt ng EA, which is the electric flux. Or in some case, wherein constant yung A, nagiging derivative lang to with derivative lang to ng electric field with respect to time. Okay? So we found out na this current is just due to the change in flux in electricity. And ginamit ni Maxwell ito to reformat the Ampere's law. So tinawag niyang si displacement current ito. Weird yung pangalan niya, displacement current. Kasi meron tayong tinatawag na electric displacement. electric displacement, which is parang electric field for dielectrics. Okay? So, wala lang. Physics terms lang ito. Kaya siya ginamit na pangalan. Kasi itong electric displacement, you can relate it with the displacement current. Okay? So, ayan. Wala lang. Hindi siya kasama sa mga kailangan yung aralin. Pero, you might wonder lang kasi bakit displacement current? Okay? Okay. So, changing electric field for dielectrics. Okay, so you have this displacement current. Then the corrected Ampere's law would be something like this. The integral of B dot dl is equal to mu naught I enclosed. Itong unang IC natin, ito yung alam natin na current na usual. And then plus epsilon naught times yung change in flux in electricity, derivative nun. So, ito yung displacement current. In essence, ganito itsura niya. Mu naught IC plus ID. Okay? All enclosed. Okay. Amazing, di ba? So, inayos ni Maxwell yan. So, we're going back to the restatement of the Maxwell's equations. So, si Maxwell, lahat gumawa nito. Parang ninakaw niya lang yung mga Gauss's law, Ampere's law, Faraday's law. Tapos sinabi niyang Maxwell's equation. Hindi. Yung Gauss's law kasi, yung Gauss's law, is for, talaga siya? Is for gravitation talaga siya. Si Gauss's law, si Gauss, may ginawa siyang paper na sabi niya, dahil smart kid si Gauss, very smart kid si Gauss. Ito rin yung mga idol na idol ng mga scientist, mathematician. Dami nilang ginawa in life. Daming Gauss's something, Gauss's law, Gauss's elimination, Gaussian something. Diba? Ang dami niyang ganap in life. Si Gauss's, ginawa niya, nakialam din siya sa astronomy. So, meron siyang ginawa na paper na theoretical na, malalaman mo yung amount of mass contained sa isang object just by feeling the gravity around it. Sabi niya ganun. Ginawa niya yan. Kasi si Maxwell nakita niya, yung gravity 1 over r squared, yung electricity 1 over r squared. Why not i-pattern ko kaya tong Gauss's law? Yung formalism ng math ni Gauss sa electric fields. And it turns out you can do that. In the same way, papakiramdaman mo lang electric field around an amount of charge, then you can determine the amount of charge that is enclosed by that calculation. Okay? So, nalaman ni Maxwell yan. Ginawa niya. And then, tinry niya rin yun sa magnetic fields and wala naman nangyari. Zero lang. Okay? And then, si Faraday's law, siya gumawa niyan. Hindi naman si Faraday dahil hindi naman magaling sa math si Faraday. Magaling lang siya mag-experiment. Okay? Wala siyang formal education and so on and so forth. So, ginawa lang ni Maxwell yan. And then, Ampere's law. Si Ampere gumawa pero incomplete. So, meron siyang dagdag na correction term. Okay? That would predict currents that are due to changing electric fields. Okay? Okay. And nicely enough, when you look into a vacuum, sa vacuum tayo pumunta. Okay? So, sa vacuum, walang charge. So, E dot dA is 0. Then B dot dA is still 0. And you can see the symmetry there. Diba? And then for these parts, in vacuum, mawawala yung mga currents mo. Kasi wala naman laman dapat yung vacuum, di ba? So wala yung mga currents mo kasi wala ka nga rin charges. Wala ka rin currents na nandito. And this is what it looks like. This is what. Ito yung itsura niya. It's very symmetric, no? It looks nice. E.dl tapos B.dA, B.dl tapos magiging E.dA. Tapos derivative with time. And then combine to the in-spoiler alert ko na. In-spoil ko na. Combine further ito ni Maxwell. Combine nyo to further. And wait now. And the resulting thing is, let me just whip it up here. When you combine things, wait lang, hanapin ko equation. Hindi nila pag-equation dito. Teka, let me just whip it up kasi I always like discussing this thing. Okay? Chill lang tayo. Yan. I got it. Kabisado, baka mamali ako. So when you combine these things, you will have something like this. So the partial derivative respect to E. So hindi nyo kailangan to. I just want to share this with you. Joke lang, baliktad pala. Okay, hindi ko alam kung familiar kayo sa del operator. Yung del operator, itong triangle na kabaliktad is just a derivative with all directions. So ito ay can be written down as the partial to x hat, partial derivative with respect to x, y, partial derivative with respect to y, plus z, partial derivative with respect to z. Okay, ganito itsura ng del operator. Okay, and then, so this is just a 3D na 3D na differential. 3D na slope. 3D na slope ito. Okay, so we have this. And you'd see that this is equal to 1 over mu naught epsilon naught partial derivative ng E with respect to time. And then another equation that will sprout from those Maxwell's equation is that ganito. So sinolve ni Maxwell's Sinolve ni Maxwell ito. Pansin niya yung symmetry between the objects, between the equations, then why not combine them? No? Why not combine them? Naisip niyang ganun. So E.dA, malalagay mo dyan yung ito, and so on and so forth. May mga gagawa ka pa. Tapos may merong mathematical pa dito. Other things na malilipat mo integral to a derivative, and so on and so forth. So gagamitan mo siya ng mga gantong operators, del operators. And you'd see that it would equate to these guys. Okay, so you get the other one, by reversing the process. Basically, may dalawang process. Kung sino unahin mo would result to the other one. So, ito. Okay? And then, itong derivative na nasa kaliwa, sabi ko nga sa inyo, 3D lang yan, na 3D na slope. So, it's a spatial derivative. Spatial derivative. Meaning, with respect to a space, and this is, the right-hand side is a time derivative. And what does that imply? These guys, they are wave equations. They are wave equations. And if you try to recall some mga itsura niya, okay, so when you have a wave F, and it's equal to something like this. So kung wari meron kang wave na F, so may function ka na nagwe-wave siya, you can always write it down into a function in an equation that defines a wave, which is the wave equation. Okay, and that wave equation tells you the speed of the wave by this. Okay, so given this, and dito makukuha yung velocity nung wave mo. And by looking at this equation, you'd see that these two waves parehas sila ng factor dito. And you'd see that 1 over v squared is equal to 1 over mu naught epsilon naught. Okay, and then v must then be equal to the square root of mu naught over epsilon naught. Wait. I think baliktad ako na nagawa ko. Okay, sorry. Kaya pala may mali. Napansin ko na siya. Well, tama naman yung process. Notation lang. Numerator pala ito. May numerator ito. Ay, sorry. Mu naught epsilon naught. Mu naught epsilon naught. Okay, and that tells me that 1 over v squared must be equal to mu naught epsilon naught. That tells me that v, the speed of these guys, is 1 over square root of mu naught epsilon naught. Okay, and this is the speed of light. The speed of light. So nagulat si Maxwell no na, oh my God. Oh my God. Ito pala implication ng lifelong work ni Faraday na wala nakasolve ng speed of light. Si Maxwell lang. Just by using math, na predict niya yung speed of light, which is just the speed of electromagnetic waves. Si Faraday, nagkaroon na siya ng hunch na electricity, magnetism, and light, they are all related with each other. Pero hindi niya na-prove mathematically kung ano yun. Pero by experiments, napansin niya na nagagalaw niya yung light through electricity and magnetism. So maybe light was related with electricity and magnetism. Then Maxwell came, tapos pinakita niya through all the math that the magnetic fields and electric fields are all waves propagating with speed 1 over square root of mu naught and epsilon naught. And nagulat siya that this number is very, very big. And it only posits that is the speed of light. So, pinuntahan niya si Faraday, no? Si Faraday, matanda na nung pinuntahan niya. Pinuntahan niya si Faraday na pinakita niya yung libro, pinakita ni Maxwell yung libro niya about the things that he have discovered. Unfortunately, Faraday, the old Faraday was Meron na siyang amnesia, nakakalimot na siya ng mga bagay-bagay. And he didn't understand the things that Maxwell have shown him. Okay? Sad. No? Na ulyanin na siya nung na-discovered ko ni Maxwell. Well, kasi medyo adik-adiktong si Faraday. So, kinukuryente-kuryente niya yung mga sarili niya. Naglalaroan niya yung mga kuryente. Yan tuloy na ulyanin siya. Okay? So, that's it for today. You may read about superconductivity. Watch videos, YouTube videos about superconductivity. And malay nyo ang superconductivity, yung mga maging field nyo when it comes to your future careers in the biochem or in chem, no, or in chem. But I guess yung asing topic na mahalaga is to understand Lenz's law. Okay, so most five questions about the exam is about the direction of induced current. Okay, or direction of induced magnetic field. Okay, so maraming bagay na ganito sa exam. And as usual, I like to give trick questions. Okay, so Gauss's law is important. Magnetism. Okay, so may mga trick question ako lagi, as usual naman. Okay, and then next week is reading break, tama? Tama ba? Tama ba? Okay. Reading break tayo next week. Tapos may meeting tayo sa Monday ng Holy Week. And that would be the last topic for your second exam. So yung topic lang naman doon ay inductance. Yung mga natitirang topic ay inductance and then inductors. Kasi meron tayong capacitors and then meron din tayong inductors. And I guess that's it. Hindi ko pinilit kong sabihin sa magkabilang class na hindi na isama yung mga alternating currents na circuits, yung mga RLC circuits, resistor, inductor, capacitor circuits. Because they are very complex and I think you don't need them in your life. Okay, after Holy Week, sure yan na magkakaroon kayo ng second exam. Siyempre, hindi naman tayo pwedeng magbigay ng exam sa Holy Week. Okay? Okay. Thank you for asking. No? Yung bagong prob set, ipapost ko after ng class natin ngayon. Nagawa ko siya nung last time, pero hindi ko na-post. Hindi ko na-post. Ano na lang, yung deadline na lang nun, okay lang ba nasa, nasa April 13? 13, okay lang ba yun? Wednesday? Well, baka wala nang pasok kasi nung Wednesday. Di ko alam kung pwede magbigay ng ganun. Pero tas parang unfair naman kung April 12. Parang hindi nyo nasulit yung reading break nyo. So, April 13 na lang. No? April 13 na lang. Papost ko na ngayon, as in, ngayon, naka-ready na siya. Gusto nyo makita nyo nga. Pakita natin. P72. Okay, dalawa yung naka-ready. Okay, so let me just show it to you. May time pa naman. Okay, so this is prob set 4. Ayan. Magnetic force, yung focus ng prob set 4. Okay. And then prob set 5 is Ampere's law. Okay? Ayan. Okay. So, yan. So, ito superposition lang naman to. Yung pangalawa. Superposition lang yan. Ito, gagamitin nyo lang yung n times something. Did we have prob set 3 na po ba? Wala pa bang prob set 3? Okay, mali. Baka mali na numbering. Okay, so, sige. Mali lang ako ng numbering. Okay, wala pang number 3. Sorry. Nagkamali ako. Kasi kasabay kong ginawa yung yung prob set nung ibang course. Tapos parang magkaka-number lang. Kala ko magkaka-number lang. So hindi pala. Delayed kulang pala ito ng isa. So ayan. Sige. Panic kayo. Sorry. I guess that's it.